There we go. All right. My name is John Chavez. I'm the host of the DMT Quest podcast. Welcome, everyone. I have a very special guest today, longtime DMT researcher, and a person I've been following for years at this point. His name is Dr. Stephen Barker. He's one of the most well-versed people in terms of DMT, especially endogenous DMT, and I admire his work greatly. Thank you very much for joining the show, Dr. Barker.
Oh, it's my pleasure, John. I've always enjoyed your questions.
Thank you very much. I know the first time I interviewed, I asked some outlandish questions. Looking back, now that I'm a little bit more well-versed in neurochemistry, but I have a lot of questions about life. So let's just dive right into it.
Sure.
How'd you get interested in, endogenous DMT and studying the properties of this molecule?
Well, I was taking a course in natural products at the University of Alabama in Birmingham under a guy named Fred Bennington, who was a hallucinogen researcher in the neuroscience program in the Department of Psychiatry in the School of Medicine there at UAB. And this was in 1972. He mentioned that they were doing research on the possibility that there was an endogenous hallucinogen in brain. That hit me like an epiphany. That if there was a normally occurring hallucinogen in brain, maybe that was related to extraordinary states of consciousness, dream states in particular. I've always been very fascinated by my dreams. I had lucid dreams very early in life, and that was part of the reason that I had pursued my interests in understanding hallucinogens. Of course, I grew up in the 50s and 60s in Birmingham, Alabama, and although we were far removed from what was going on in California, I read intensely about the discovery of hallucinogens and their effects, and I wanted to know more. So when it became known to me that they had discovered dimethyltryptamine and 5-methoxydimethyltryptamine in the cerebral spinal fluid of schizophrenic patients there at UAB, I just wanted to be involved in that work. So I did end up doing my PhD in the Department of Psychiatry in neuroscience program under Fred Bennington and several other workers there. Dr. John Smithies, one of the originators of biological psychiatry, he and Humphrey Osmond both were in that laboratory. Dr. Smithies ran the neuroscience program there. And they were the originators of the idea that schizophrenia might be caused by an endogenous psychotoxin, is what they originally phrased it. So once I learned all that, I wanted to pursue everything I could about endogenous hallucinogens.
Okay.
And I've been doing that now for over 40 years.
So one of the controversies regarding endogenous DMT is where it's synthesized in the body. Do animal studies translate to human studies? Right. Let's start with I guess we can go with the lung discussion regarding the whole INMT and DMT. Can you discuss a little bit how that came about?
Yeah, I can understand why there's some confusion, because there's yet to be enough scientific data generated to actually conclusively answer that question. But let me kind of give you a little background. There were studies done on the source of the enzyme responsible for the biosynthesis of DMT. Those studies were looking for the indole N-methyltransferase. Now, it had already been shown that DMT could be synthesized in the brain. Julius Axelrod and people in his laboratory had done studies in the 60s showing that an injection of tryptamine, which is the precursor for biosynthesis of DMT, and it comes from tryptophan, when injected into the cistern of the brain in rats, that they found biosynthetic DMT in rat brain. And they isolated and identified the enzyme as being they classified it as an N-methyl transferase. It puts two methyl groups on the side chain nitrogen of tryptamine, making DMT. Others then went to work. Dr. Thompson studied the occurrence of that enzyme in other tissues. And he found the highest concentration of that enzyme to be in the lung. Right? And again, this was done in rats. They eventually completely sequenced that enzyme and identified the gene for it. And it was then thought, of course, that with the highest concentration of the enzyme being in the lung, then surely that's where DMT is biosynthesized. And the reason that explanation was so readily accepted was the idea that DMT is actively transported from the periphery through the blood-brain barrier into the brain. Right? So what a unique situation, synthesized in the periphery and the lung. The lung certainly responds to a lot of physiological changes that we undergo, fight or flight, fear, where we hyperventilate, or meditation was certainly immediately coming to mind with a lot of individuals, that this was how this was happening, that these altered states were being created from the lung, being transported to the brain. Those studies that Thompson did, unfortunately, didn't readily identify any N-methyl-transferase in the brain. Right? But this was due to the techniques they were using. Right? So for a very long time, it was thought that so you were going to have to get a level of DMT from the lung that was the equivalent to what you see from injection or smoking or consumption of DMT by some other route. The concentration would have to be sufficient to produce a hallucinatory state. So it was thought that high concentrations in the periphery would be necessary. So that's where that came from, and that's why people have adhered kind of to that idea. Unfortunately, that it may be that is not quite correct.
Yeah, it seems like the 2019 study published by Dr. John Dean kind of threw everybody for a loop in terms of a much more comprehensive perspective of DMT synthesis in the mammalian brain. I guess one of the things that caused some controversy was Rick Strassman's hypothesis that the pineal gland was the predominant source of DMT. He speculated that in his book, DMT, the Spirit Molecule, and I think it was published in the year 2000. And then I guess that warranted maybe a little bit of criticism. And then Jima Borjigan and yourself worked on an assay or a study to go ahead and verify whether the pineal gland did produce DMT. Can you speak a little bit about that study?
Sure. The interesting thing about Rick's hypothesis is, that biosynthesis in the pineal gland without any further supporting evidence made it appear to be very speculative. Right? But we know that there are other hormones produced by the pineal that are related to tryptamine and DMT, melatonin, which I'm sure everyone's quite familiar with. But he had a background, and Rick does have a background in religious philosophy and psychiatry, and he was synthesizing an idea, a hypothesis to be further examined from all of his background and knowledge. Well, again, we were working against this idea that DMT was only being produced mainly from the lung or from the periphery, that there was no INMT, endo and methyltransferase in the brain. So what are you talking about, Rick? You know, it was that kind of thing. Plus his hypothesis went further as it being the spirit molecule, also upset a number of people who are more attached to other explanations for their beliefs in extraordinary states of consciousness and afterlife and near-death experience and all that. So, of course, everyone's entitled to their beliefs, but science deals with facts. So we set out to get the facts. You know, what are the facts? Well, the facts turn out to be from the study I did with samples from Dr. Bourguignon at the University of Michigan. She sent perfusates of what turned out to be, it was the pineal gland and the visual cortex using transfusion material in rat brain to perfuse the areas around those tissues, then collect them. And then we collected those samples and tested them. Well, the perfusates from the pineal and visual cortex of the rat showed by unequivocal scientific evidence that DMT was present in those perfusates, and thus had to be present in those tissues. So we did not quantitate it at the time. We just were trying to find out whether or not it was there. The studies that followed on from that, we published a paper where John was the primary author in Bourguignon's lab. And what was shown from that was an examination of the presence of endo-methyltransferase using other molecular biological techniques that showed its activity and synthesis of the enzyme. So what came out of that is that the pineal gland actually contains very high concentrations of that enzyme. It also contains the other necessary enzyme for the biosynthesis of DMT. You don't get DMT unless you get tryptamine, and you don't get tryptamine unless you have an enzyme that removes the carboxyl group from tryptophan, which we get commonly in our diet. You know, concentrations of tryptophan in the body are very high. That enzyme, the amino acid decarboxylase, aromatic amino acid decarboxylase, or AADC, was co-localized with endo and methyltransferase. So, I mean, what better relationship could you have if you want to make DMT? You have the two enzymes there together, taking tryptophan, making tryptamine, tryptamine being methylated by INMT to make DMT. And we were seeing DMT. Again, he also found very high concentrations of this enzyme in the choroid plexus. Now, the choroid plexus, the pineal gland sits in a position in the brain where it secretes materials into the cerebral spinal fluid. Well, the cerebral spinal fluid comes from the tissues that line the ventricles of the brain, and it's called the choroid plexus. And now those cells there also contain very high concentrations of the enzyme endo and methyltransferase and the AADC. Right? So again, the choroid plexus probably does that as well. He also looked at the visual cortex and several other areas of the brain and found similar co-localization of those two enzymes. So now we have evidence, one, that DMT is being found from perfusates of the tissues, the visual cortex and the pineal, where there is also a very high concentration of the known enzymes for biosynthesis of these compounds. We have the enzyme in the brain. We know that Thompson's work was incomplete. And we know that there is overlap between those major enzymes, making it possible to not only synthesize this, but to respond to increase or decrease synthesis by regulation of those enzymes in the brain. So again, part of that study that John Dean did, Dr. Dean, he measured the amount of DMT that was being produced in the same brain area using other perfusates, continuing the study. They also measured serotonin levels, which are also produced in those tissues, melatonin and several other compounds. But the important thing that came out of it was that the concentration of DMT that was being seen from those tissues, and again, we didn't measure it when we originally discovered it, but Dean did measure it, and he found that the concentration of DMT was consistent with what was being seen for the other canonical neurotransmitters in the brain, right? So it wasn't that DMT was just a trace artifact or wasn't some terminal end material that was intended to be cleared from the brain and excreted with no effect. Here you have a known hallucinogen being produced at concentrations consistent with other neurotransmitters in the brain. I don't want to say voila or ta-da, but it's pretty close to that in having that evidence. Of course, this is all being done mainly in rat brain, but John did do some tissue slices from humans and found a similar distribution of those enzymes in those tissues. And there had been human studies done in the lab at UAB when I first started in early 1970s. Smithies and Corbett and Dr. Bennington and several others identified DMT and 5-methoxy-DMT in the cerebral spinal fluid of schizophrenic patients. But they also discovered it in the cerebral spinal fluid of normal patients. Right? So I've got to stop the cat from banging on the blinds. So they're all the fun I have in a day. Being retired, it can be very boring without cats. That's why so many people have them. So all that information taken together, it's still. Let me throw something at the cat. Stop it. Hey. So the evidence now is that, and the other thing that Dean found, the enzyme, the endolymph methyltransferase that is in the lung is indeed very high concentration. But what he found is that it is not co-localized to any major degree with AADC. So how is it that the lung can get access to tryptamine and synthesize DMT at concentrations necessary to circulate in the periphery and go to the brain? We think that's evidence that it probably doesn't, because the thing about tryptamine is that it is very rapidly metabolized by monoamine oxidase, as is DMT, right? But if it's being produced in the periphery and it's not going directly to the brain, which it can from the lung, it can be synthesized, go directly to the lung. There is MAO in the lung, there is MAO in the blood. It may be destroyed before it ever has a chance to reach a concentration where it could have any effect. Likely in the scenarios that have been proposed, talking about significant quantities that produce extraordinary states of consciousness. All the organs communicate with the that circulate from the periphery to the brain to tell the brain, we need to increase respiration. We need to respond, by slowing, especially by signaling molecules. It may be that DMT in the periphery is just that for the brain. It is a signaling molecule. But this enzyme also is responsible for methylating a number of other compounds, like histamine. Histamine is methylated in tissues by methylating enzymes, and this particular indolymethyltransferase has been found to also methylate histamine. So its presence in these other tissues may not be necessarily to methylate DMT.
Yeah, one of my issues, I guess, in reading some of the criticism.
That's more than an answer.
I love it. It's beautiful.
Yeah.
One of my issues with the criticisms was that, I guess, the initial criticism was that the pineal gland is probably not sufficient to produce enough DMT in order to cause any sort of physiological effect. At least that was the criticism. And then Dean came out with the paper, with you guys, the whole team came out with the paper, and he showcased that, like you stated, DMT was found in levels comparable to serotonin and dopamine. That should suffice. It's not like a voila, but at the same time, it should be acknowledged in the sense of, if you're going to have an initial criticism that there's not enough DMT in the brain, then the data showing that there is enough DMT in the brain to comparable to known neurotransmitters, then we should go ahead and start to change the conversation about any sort of debate. And I don't feel like that happened. I feel like just it's almost like the goalpost got moved a bit.
No. Well, it was very unfortunate, I think, that Dr. Dave Nichols, who has a very strong reputation, deservedly so, in hallucinogen research. I think, proposing that a compound that has been discovered in brain that is a known hallucinogen. He made these comments about what you just described, that it wasn't high enough concentration to have an effect. He said that was true before we even knew what the concentration of DMT was in brain. Now that's just not something that should have been done. Comments that were published, basically describing the fact that we needed to know how much was there before we make that kind of determination. And his reply to my rebuttal was, "Well, then go measure it." Well, that's what we did. And like you say, I think that argument is now somewhat disproven as a bit of unnecessary hyperbole before all the results were in. I haven't seen a withdrawal of that claim, and I don't expect to. All of this does involve the possibility that DMT has some neuroregulatory function and may be an answer to our inability to really define how hallucinogens work, how we experience some of these extraordinary states, like near-death experience, creativity, imagination, dream states, all of that, right? We don't know how that works. Just like, before the discovery of the opioid receptor and the endogenous opioids, we were explaining how morphine and the opioids worked based on the only known neurotransmitters at the time. So you can read literally thousands of papers about the mechanism of action of morphine that just turned out not to be true.
That's amazing.
Yeah. So the same may happen here, and I'm certainly pressing for people to do much more research on endogenous DMT to find out what its normal role is. Because, I mean, let's face it. I mean, well, here are the facts. This compound's there. It's in the same concentration as a lot of the other normal neurotransmitters. Of course, this is in rat tissue, and we do know that the translation, what goes on in rats, in both genetically and physiologically, there are very close parallels. And I would find it difficult to believe that this would not be the case in humans, especially given the fact that this compound has been reported in humans. But we need to accept the fact that its normal role, it has to be something other than extraordinary hallucinations. If that was its normal role, we'd all be hallucinating all the time. Not that that would be a bad thing.
Maybe we are.
And some people think that we actually are. I mean, and I'm not going to argue with that either. Perception is a process that goes on through the brain, and we process the external world through what we do internally, and that it's a hallucination of sorts, not far from the truth. Depends on your definition of hallucination.
Can you speak?
But its normal role has to be some regulatory process that is more likely than not related to processing and our incorporation of that data and our synthesis of that information into what we call reality.
Can you speak a little bit about how serotonin itself got established in terms of its role in our perception and things like that? Because I mean, it's the most well-known, or one of the most well-known neurotransmitters out there. And I guess for the public to understand how DMT would get established, we need to know a little bit about how other neurotransmitters have gotten established in terms of how we understand that they play a role in the body.
Yeah, well, first was its identification in the brain. And of course, serotonin is also in a lot of other tissues, but particularly in the brain, along with other compounds that were identified as compounds that stimulate neuronal tissues to send a signal. Basically, that's what a neurotransmitter does. Helps regulate the activity of the neurons and transmission of signals between and among neuronal cells and other cells in the brain. Glia are also involved. So the neurotransmitter serotonin, it was found to be distributed very widely in the brain, but was more concentrated in certain areas. This was done by typical brain slice binding studies. The olden literature, olden, my God, was when I was a young man. You do brain slices and you take radio labeled serotonin and you put it over the tissue and then you wash it. And then you take the punches of the brain areas and you put them in scintillation vials with counting fluid, and you put them in a scintillation counter, and and you get radioactivity that is isolated in those areas. And that's where serotonin was binding. And so it was binding to something. Well, it's binding to receptors. These are proteins that are produced from a gene in neuronal cells that sit on the surface and penetrate into the internal part of the cell that carry the signaling information from the molecular binding of a compound to a change in the structure of the protein that it's bound to, that sends a signal on the inside of the cell that causes it to charge or discharge. And basically, it's acting like a little battery. Right? Molecules are basically little circuits. They have electron distributions on them that are specific because of their structure, and they bind specifically to enzymes that send specific messages to the cell. And the same thing with the internal workings of the cell. They know what those messages mean and what they should do. So serotonin was identified. And when hallucinogens were tested, it was found that one of their major effects was that they greatly elevated the level of serotonin in the brain. Thus, it was thought that the mode of action, the hallucinatory experience, and of course, some other effects of some of the hallucinogens were due solely to changes in serotonin levels in the brain. Right? But that may not be the only thing that they do, and that the hallucinogens may actually be acting on the endogenous hallucinogen pathway, and the neurotransmitter for that is DMT, not serotonin. Does DMT affect serotonin? Yeah, it elevates it. But if you just normally elevate serotonin using other compounds that are not hallucinogenic, the effect that you get is euphoria, right? And a lot of the antidepressants work by elevating endogenous serotonin, but they don't cause hallucinations. Hallucinogens are a unique class of compounds that specifically affect perception. Right? They alter how we are processing sensory information, how we're incorporating that sensory information, how we're synthesizing new information from those external senses, and what we normally do with our internal senses. Right? So, the idea that serotonin alone is somehow involved, is responsible for the mode of action, isn't quite right. So what we haven't done with DMT is to do what we did for serotonin. We need to map DMT in the brain. There are some research labs that are in the process of doing that. We need to better understand regulation of the enzymes that are involved, and perhaps what drugs are already interacting with those enzymes to either upregulate or downregulate, either at a gene level or at the binding sites that are responsible for release and reuptake of these compounds as neurotransmitters, which is common to all neurotransmitters. It has to be something that synthesizes it, something that releases it, something that binds it, something that reuptakes it and stores it. Right? And that work was actually done back in 1980 by Dr. Terry Christian. He was a gentleman who I did my postdoc with there at UAB. He characterized DMT as a neurotransmitter. He showed that it had all the properties of a neurotransmitter for those processes, long before we actually proved that it was present in rat brain. He was part of the studies identifying it in the cerebrospinal fluid in human brain. So we still need to do that, and we need to look at, since we have perfusion techniques that will allow us to quantitate the amount of DMT in different brain areas. This could certainly be done in animal studies, is administer LSD, see whether or not LSD causes an increase in the endogenous level of DMT. Administer psilocybin and see whether or not it causes an endogenous level of DMT to go up. There, these other hallucinogens may be agonists of an endogenous hallucinogen neuronal system, right, that acts just like the other neurotransmitters. You can have things that cause increased release. You can have things that cause increased uptake. You can have drugs that cause reduced reuptake, which greatly enhances the potency of that neurotransmitter. So it may well be, and it's one of my long been one of my hypotheses, article I published in 1981, that an explanation for the mode of action of hallucinogens is its action on an endogenous neuronal hallucinogen system. DMT is the transmitter, perhaps 5-methoxy-DMT coming from serotonin, that is acted on by these compounds as either agonists or antagonists, thus altering its levels and causing the effects that are observed.
Can you speak a little bit about bufotenin? It's kind of a, is that considered a metabolite of 5-MeO DMT?
Well, it's always been a little confusing on Bufotenin because there has been no publication that has shown the presence of Bufotenin in human brain. And I don't think in rat brain. I'm not really sure about that. I did a paper in 2016 where I reviewed all the studies that have found these compounds, Bufotenin, 5-methoxy-DMT, and DMT, in blood or urine or brain or in some other tissue. But Bufotenin is not necessarily, it was certainly not a metabolite of DMT, but it may be a metabolite of 5-methoxy-DMT. It depends on, or it may be just biosynthesized in its own right, directly from serotonin. It does bind to the methylating enzyme, and there's an abundance of serotonin in the brain. The question is whether or not it is a true hallucinogen. People have, administered Bufotenin in manners which lead to hallucinatory experience. So I have to believe that that is probably true, that it is a hallucinogenic compound, and its binding known receptors puts it in the same category as the others. Its potency is debatable because other routes have either no effect or very little effect. And there has been, but here's the thing, there's been far less work done on Bufotenin than on the other two compounds. So a lot more work needs to be done on Bufotenin to determine whether or not it is a true hallucinogen and whether or not it is part of this hallucinogen neuronal system.
Okay.
Haven't ruled it out.
So in our DMT Quest documentary, we did feature a short clip of yourself discussing the unpublished study showcasing that LSD administered to rats upregulated 5-MeO DMT, endogenous 5-MeO 1,000%, and endogenous DMT 400%. Can you speak a little bit about that unpublished study?
Yeah, it's one of those things where, damn it. We really needed to pursue that. And I was doing this at about the time that I was leaving the department at UAB and going over to run the Comprehensive Mass Spectrometry Center in the Department of Chemistry. And it was a study that I was conducting with Dr. Robert Harrison, who had been a postdoc in the department at the same time I was. We took a group of rats and we administered LSD to the rats by an intraperitoneal injection. Now it's interesting, this LSD was still in some of the original bottles that had come from the labs where LSD was originally synthesized. It was fairly old. So we were in part doing a biological determination of whether or not it was still stable, that it was still LSD. Dr. Hoffman had provided these vials to Dr. Bennington, who was my major professor, who was friends with all these people, Sasha Shulgin and Albert Hoffman, and all these guys knew each other. I think they freely synthesized these compounds and got together and had many parties. Anyway, we administered this intraperitoneally. We waited an hour. We observed the rats to see whether or not there was head twitch or what's called Straub tail, a curling of the tail from increased serotonin. And we did see that. We sacrificed the animals and collected brain tissue. This was only done on 3 rats, right? It was a preliminary study. to see whether or not DMT was elevated and whether or not 5-methoxy DMT was elevated in brain after administration of LSD, to address this hypothesis that there was an endogenous hallucinogen neuronal system, or perhaps LSD, not really a hallucinogen. It is just an agonist of that system that elevates endogenous DMT. Well, we analyzed the data by gas chromatography, mass spectrometry, which is an unequivocal identification of the compounds, and we found elevations, rather dramatic elevations of DMT and 5-methoxy DMT in the rats. Well, wow, so we planned to pursue this I was going over to the mass spectrometry center. Dr. Harrison was going to do the rats and have access to the hallucinogens there in the lab. And we were going to do a larger study. We put it in several grants that were being submitted from the department to get funding to do this. You can't do any of this on a large scale without money. Well, the grants did not get funded. The NIMH looked at it and went, eh. So, we couldn't get the money, but, so we planned to kind of bootleg some of it. Well, then Dr. Harrison died. He had what we didn't know at the time, stage 4 cancer, and died right after he finished defending his dissertation. And his dissertation was never published. He had demonstrated that DMT and 5-methoxy DMT were elevated in rats undergoing stress, elevated in both brain tissue and in adrenal gland. Right? But that data is still sitting in his dissertation. It's never been put out there. So that was the thing. I did not have a drug license, the DEA license, to work with hallucinogens at the time. So I was unable to do that work. And I have not been able to do that since. I've not had access to the funding or the animals or the hallucinogens such that I could easily do all of that myself. I tried to cajole or otherwise tempt other people into doing it. Anybody out there who wants to do that work? It's just waiting. Yeah. But hopefully that work will get done now. Again, we were working against the ability to get the funding done because of the lack of interest in hallucinogen research, through the 70s, 80s, 90s, and what was being considered as insufficient evidence that it's a compound of relevance. Much like Dr. Nichols has tried to paint DMT successfully, I think, in some cases, but hopefully now it's becoming more accepted that it is a endogenous hallucinogen of interest.
Yeah.
Yeah.
I mean, one of the things, going back to the Nichols criticism, is that he wants to state that DMT as a singular compound can have an effect, but at the same time, he seems like he wants to swap out DMT for dynorphin. I guess that's an endorphin. And what's funny is that I recently came across a dynorphin study in which they gave dynorphin intravenously to humans at the same levels as Rick Strassman gave DMT to humans, and there was absolutely no report of the dynorphin subjects having any sort of hallucinatory effect. That's why it's like, I don't understand the inconsistency in these arguments. Maybe I'm naive. I'm not a scientist. I'm just a spectator, but I see a lot of inconsistencies.
Yeah, I mean, there have been many hypotheses about what causes schizophrenia, what causes hallucinations, with the discovery of every new compound or pathway or neurotransmitter over the centuries now. There has been, some changing hypotheses. But, opiates, can of course produce hallucinatory phenomena. And there was an interesting study, group of papers that was published by Dominic in the 70s, where he showed that administration of opiates potentiated the effect of hallucinogens. Are you aware of those? Yeah. So, it could be that opiates have an interface with the neuronal system that's responsible for the mode of action of hallucinogens, which may be this endogenous hallucinogen neuronal system, and that opiates may play a role. Endogenous compounds. Certainly, Rick showed that oxytocin goes up, DMT administration. If it's a naturally occurring neurotransmitter, it does have some natural role, and there is not a single neurotransmitter in the brain that doesn't interact with a number of other neurotransmitters and signaling molecules. So the same is true of DMT as a neurotransmitter. What all it interacts with, what all affects it, and what all it affects is insufficiently understood at this time. And what I'm hoping is that further research is going to show that it can explain any number of phenomena, such as what happens when you directly administer these in fairly high concentration, but also things like regulation of perception, which we don't understand, creativity, imagination, dream states, altered states, and any number of phenomena. What happens from the from meditation, the states that can be attained by whirling dervishes, and all these physiological things we can do without actually adding a hallucinogen to the system, that it will allow us to begin to understand that and begin to better understand the disorders of perception, and to better perhaps affect our ability to perceive and understand, to synthesize information from what we do perceive.
It's interesting that you mentioned your colleague that passed away, the research he did regarding stress upregulating endogenous DMT and endogenous 5-MeO in the rats. What do you think about that translating to like cold immersion? People who, I guess, take cold showers or do the cold plunges with the ice, like the Wim Hof thing. Do you think that potentially could have a similar type of effect of upregulating the DMT and 5-MeO?
Yeah, the Wim Hof technique may be similar to something like a fight or flight response. When the body is put into dangerous circumstance that causes dramatic physiological change, a number of the neurotransmitters respond by being elevated or downregulated. It just depends on what the response needs to be. And a lot of the research that's currently being done on the effects of DMT on patients that have different perceptual and neurological disorders are starting to see the other things, the other pharmacology of the hallucinogens. Certainly, under extreme circumstance, you can see an elevation of these neurotransmitters to the point where you start to get perceptual phenomena that are different from normal. And of course, we've tried to define those different from normal perceptual events as a variety of different things that you could tag with religious phenomena or mystical phenomena or just damn phenomena, but there's there's got to be nothing happens that is not regulated by a neurotransmitter in perception. Nothing, right? So there's got to be something that's doing a coordinated response to that external phenomenon that is causing that. And I think having a known hallucinogen in the mix really helps us explain some of that.
What do you think about some of the neuroprotective and anti-inflammatory effects of DMT? Do you think that we're getting closer to establishing DMT as being an endogenous anti-inflammatory compound?
Yeah, I think so. And again, I think this goes to its role as a naturally occurring neurotransmitter. If it's not routinely just causing outstanding, awesome hallucinations, what's it doing? But it turns out that DMT is a very potent anti-inflammatory agent, and it protects neuronal cells against hypoxia, right? Which is just an amazing thing. I mean, I don't think anybody really thought that this could happen, but it also greatly enhances neuroplasticity, the ability of the brain to self-repair, right? People thought for a long time, you got so many brain cells and you die with them, right? But no, I mean, the brain actually does have the ability to regenerate these brain areas, this protection by DMT of hypoxic events. It kind of underscores a different pharmacology for it. It may help explain some of the altered states that are observed. One of the other studies that we did, of course, was in John Dean's paper and work done by Jimo Buljian. DMT is elevated in the brain of rats when we induce cardiac arrest. So in cardiac arrest, the phenomena that starts is cessation of blood flow in a hypoxic environment for the brain. And this is where we see this rather dramatic increase in not just DMT, but in other neurotransmitters. But DMT goes up in a significant way. And given this new pharmacology that has been identified for DMT, that it has an ability to enhance neuronal cell repair and to preserve neurons, and an anti-inflammatory effect, that this may explain why we have hallucinations that are called near-death experiences, is that the level is rising to protect the brain. It is an acknowledgement physiologically that there is a threat of death, right? Of existence. So, we're trying to protect the brain as being important to being able to save the entire organism. And that may be what happens. Now, in other circumstances, a similar thing may be happening in stroke, in Alzheimer's, and other types of brain degenerative diseases, where you also see alteration of perceptions, an inflammatory process that goes on in the brain. And recent paper that we published here at LSU, there was an effect of a farm wasca. We administered DMT and a harmaline mixture. So an MAO inhibitor, which is harmaline, is found in ayahuasca and DMT. In rats trained in a couple of behavioral paradigms that mimic PTSD. And what we mainly saw was a decrease in the inflammatory process. And it seemed to help the rats recover from the trauma that they were experiencing in the experiment. Exposure to bobcat urine and things like that, and stressed them. So there's interest now in DMT being used to treat Alzheimer's. Let's see whether or not it helps regenerate and repair neuronal tissue. In stroke, where hypoxia causes the most damage, perhaps it would help stroke victims to not only get blood clot dissolving drugs, but to also get an injection or infusion of DMT or a related pharmaceutical that may come from this. This is the other thing about the hallucinogen research that's going on now, the perhaps therapeutic and useful effects of hallucinogens. Thank goodness it took forever to get to this point, but we're there now. Is that there may be other drugs that take advantage of the binding of DMT's structure in certain component parts, right? So you don't have to have that exact structure, but you could have other structures that are even more potent in having this neuroplasticity enhancing effect or antioxidant effect, or protecting against hypoxia. And apparently that is the case, because I recently saw a paper where a analog of DMT, where the side chain diethylamine dimethyl group was moved from the 2 position around to the indole nitrogen, and it had all the pro neuroplasticity effects and anti-inflammatory effects, but it wasn't hallucinogenic. So there's more to it than we know right now, and there's much more research that needs to be done. But I think it does have promise along with the other hallucinogens as therapeutics.
It's an intriguing situation, that's for sure.
Oh yeah.
Going back to the near-death experience, the mechanics of that. I don't know if you saw it recently. Paper's been making the rounds where they did, I think it was just a one-person case study, but they saw almost like a replication of the animal study that Jima Borjigan did in terms of the EEG measurement. And they saw, I guess, a global gamma, surge in the dying human patient. Did you see that paper recently?
I did, yes. Yeah.
Yeah.
Yeah, I mean, we haven't studied death near enough. And, the processes that occur. Now, of course, the near-death experience only occurs in a small portion of number of patients that actually experience death. Of course, the number of patients that experience death and go on to real death, you can't get too much information from. They usually don't relate things to you very well, right? You try to put a pen in their hand and it just, it's nothing. So there's a phenomenon where this happens in some patients, but not in others. But of course, it may involve the nature of the death. Things that cause, of course, as you're dying, you become more and more hypoxic. So that is truly the case, but it depends on the type of disorder that's causing the death that causes the elevation. It may be a variety of things. We haven't even looked at that yet. Yeah. But I know that there have been several papers that have come out that have talked to people that have had the near-death experience and have taken DMT or other hallucinogens, and they correlate the DMT experience much closer to the near-death experience than any of the other compounds. So, it is all circumstantial evidence. Every bit of it is circumstantial.
Yeah.
The actual proof is going to require more information, but you don't get to do that research if you don't speculate about the possibilities. And the possibilities right now are just phenomenal. I would love to be that 20-year-old that heard about DMT and brain again and have another 60 years, to do this work. Because I think it's going to open vast new pharmaceutical capabilities, therapeutic possibilities, and a better understanding of human perception, what is myth, what is fact, and where all of these phenomena arise in the brain.
Absolutely. I mean, one of the issues that we're dealing with right now, I hope that this won't last much longer, is that there's much more funding available for exogenous psychedelic development and research. And for whatever reason, the endogenous DMT, endogenous 5-MeO DMT funding hasn't really been flowing in, but hopefully we can continue to make more noise and alert the public that we need to go ahead and get this thing going. It's been many decades in the process of a lot of interest amongst the public, but that needs to translate into funding for the scientists, right?
Amen, brother. Yeah, I'm not going to argue with that. It would have been great, if back in the late 70s and 80s, when there was a group, there at UAB that actually tossed around these same ideas, things that we're identifying today, as being useful, and the pharmacology of these things is being better defined, and its therapeutic use is being understood. If we could have gotten the funding to continue to pursue those ideas, we'd be way ahead of the game by now. But that was the world then, and we have the world now, and I hope the world now will embrace all of this with open arms and realize that compounds don't know politics. They have certain uses in pharmacology, then we should examine them to the benefit of humankind and to the benefit of our own knowledge, because Lord knows we need it.
Absolutely.
And I'm an atheist, so when I say Lord knows, I don't. That's just how I was raised.
I got you. One of the other components to the endogenous hallucinatory system, we talked about DMT and 5-MeO, but a lot of the public isn't really that well aware that humans actually produce endogenous monoamine oxidase inhibitors. What do you think about that system interaction with DMT?
Yeah, I'm sure that the whole system responds in kind to its programming, and it says that if you need to increase the levels of a neurotransmitter that is sensitive to degradation by monoamine oxidase, that you would downregulate MAO, that you would perhaps upregulate the inhibitor and cause a suppression of that. If you want the concentrations to be greater in the cleft of the neuron, the reuptake of it is diminished by reuptake, endogenous reuptake inhibitors, or by the changes in the receptor. So the reuptake does not occur as efficiently. So yeah, the complexity of all of this is tremendous, but we can put the blinders on to look at individual components one at a time, and then synthesize what they do together, make a hypothesis from that, and then test that. So we're again not at that stage just yet with the endogenous hallucinogens, but hopefully we'll start to see that. What I'm truly thinking that may occur is that as more and more of these compounds are shown to have beneficial therapeutic effect, that big pharma will lurch into the field, and you will see more basic science research being funded not only by private industry, but also by the federal government to examine these things because of the ability for them to be so beneficial. I mean, we know, like you said, we're giving the compounds now, but in truth, we really don't know how they're doing what they do. Right? We're seeing what they do. We can measure kind of what they do, but we don't really know how they're working. And to be able to design new therapeutics, we have to better understand the exact mechanisms. A follows B, follows C, follows D, and C happen. Really, the true pharmaceutical and pharmacology and physiology on all of this. So, please.
Yeah, I mean, I think that I guess with more companies, pharma drug, Algernon developing the sub-psychedelic DMT therapies, I think that's going to change the conversation altogether and probably get a lot of big organizations more comfortable dealing with the compound, right?
Yeah. Well, right now it's having to be administered by, IV injection or infusion or smoking or, ayahuasca, which is a very complex mixture of compounds. But I did see a patent the other day from an oral form. It's a tablet of DMT, but in a form that is not metabolized by monoamine oxidase. So, an oral tablet where you can do it without having to have a huge intervention of medical personnel in order to do an administration, which you have to do with IV and other forms, should greatly enhance the suitability of the administered drug. I don't know if you've ever had ayahuasca, but it tastes horrible. But it works, which is the more important. And of course, doing IV infusions and all that very effective, affects the patients in ways that you don't want to have to do. So an oral version would be very nice. What they use is a deuterated form of DMT, and this company has patented several processes for administering different types of deuterated DMTs that don't easily metabolize by monoamine oxidase. I published that in 1982.
Wow. One of the things I noticed,
it's just now becoming a therapeutic.
Wow. One of the things I've noticed is that there seems to be such a singular focus on the 5-HT2A receptor in terms of its effects on perception. I came across some papers over the last couple of years regarding this thing called heteromerase. I don't even know if I'm saying it right. Have you heard of that term in terms of it's almost like a combination of receptors?
Yeah, heteromerase. Yeah, a lot of these receptors, in order for them to work and actually bind the specific structure that you're looking for, have to come together. And so some of them are dimers, right? Some of them are trimers, some of them are heteromers, right? We have 4 units, 3 units, 1 unit, right? So, and that's the case. Excuse me. Apologize, I've had a cold. I think I still have a cold. My wife gave it to me for Valentine's Day. Isn't that nice of her?
Beautiful.
And I won't say how I got it, but there's an understanding of the binding of these compounds in 5-HT, the 2A, and the other 5-HT family, of course, because like DMT doesn't just bind 5-HT2A. I mean, it binds a number of different types of receptors. And one of these receptors may be the endogenous hallucinogen neuronal system receptor. It's just that we're calling it a 5-HT because it also binds 5-HT. 5-HT may help regulate the levels of DMT. It could work the other way. Right? So that's been focused on, like I say, much like the idea that morphine worked through a number of different other major receptor systems because we didn't know about the other receptor, about endorphins and enkephalins and the opiate receptor. So I think that's the thing. And there are combinations of receptors that have to come together, or combinations of proteins that have to come together to form the proper receptors. And that's what you were talking about in heteromers.
Yeah, because I've seen some papers where in the heteromers were a combination of 5-HT2A and even like cannabinoid receptors. And those technically, I mean, I guess traditionally speaking, cannabis activates the cannabinoid receptors, not 5-HT2A, but there was a paper stating that I guess cannabis can induce hallucinations based on 5-HT2A activation based on the heteromer relationship. So I guess my question is it possible to activate 5-HT2A via the heteromers that are activating the other, I guess, receptors like a cannabinoid receptor, even a melatonin receptor? Is that possible?
Absolutely. Yeah, absolutely. When I was taking neuroscience, it was believed that neurons only contain one neurotransmitter per neuron set. So in a cluster or a group or an area of the brain, it was that one receptor. Of course, then it was fairly quickly proven that no, there are multiple neurotransmitters in these systems, and there are multiple receptors for those neurotransmitters. Then it was further discovered that these receptors often act in concert. So you don't get this effect unless it's a combination of these two, right? Or these four, or whatever combination you want, acting together with their neurotransmitters signaling to the next neuron. So yeah, I mean, it's again the complexity of the neuronal system is not fully appreciated, and certainly not fully understood. I mean, if we fully understood it, we can fully appreciate it. But the interaction of these neurotransmitter receptor systems with one another has been going on without us knowing it. They don't care whether we know it or not. They are doing what they do, and we're slowly discovering what they do. Right? That complexity, gives the flexibility of neurons to respond to the very different information that's coming in from external sensory perception and from internal physiological communication. It's doing a lot more than we can ever be consciously aware of. Yeah. So, yeah, I mean, there's no doubt that cannabinoids, when administered in the right doses and in the right form, can also produce extraordinary states. That it can act as an antidepressant. That it can do a number of different things. And same thing. A lot of these receptors are kind of dirty. I mean, compounds will bind to them that wouldn't, at their normal concentrations, wouldn't be effective. But if they're external compounds that are not normal to the body, in high concentration, they will overlap with those receptors, and they will bind to a certain degree and affect those receptors. It can be kind of a mass action effect. But you'll see with any drug, any naturally occurring compound, there are receptors that, when overstimulated, affect other receptors.
Do you know if there's any compound naturally produced in the human body, any compound at all, that is known to have no effect, no function in the body?
Not, not really. I mean, the things that we think have no effect, we haven't studied enough, probably.
Yeah,
I
the
mean,
reason
yeah, go ahead. I'm sorry.
I mean the reason why I asked that is because that's one of the flimsiest arguments or wrenches thrown in terms of the DMT debate, that it's,
Oh,
oh, you know, it's just floating around and might not have any effect. And it's like, do we know any compound that has no known effect? Because if we don't know of other compounds that have no known effect, then why would we be throwing that into the DMT discussion?
well, the thing is the body, when it's done with something, will metabolize it for clearance, right? So it's converted usually to a more lipophilic, or I'm sorry, a more aqueous soluble um, compound, so that it can be carried by the blood, to the urine, or through the liver. It's converted to a more water soluble compound or other compound, and then excreted in the feces. And of course, we exhale some compounds, and some come out on the skin and sweat. And we get rid of a lot of stuff that way. Buildup of those materials would otherwise be toxic. So there's the need to remove those compounds. But even in causing toxicity, these metabolites do something. I mean, they have an effect on the system. But here's the thing: the argument that you're talking about is again from Dave Nichols, that DMT was just a metabolite that was to be excreted. It didn't really do anything. It wasn't high enough in concentration. Right. Well, the concentration thing, I think we've refuted. But methylation of compounds is an energy requiring step, right? And it requires ATP and the enzyme and of course the source S-adenosylmethionine for the methyl groups, and tryptophan for its biosynthesis. If it were a metabolite, it would be like tryptamine. Well, tryptamine is already very easily metabolized by monoamine oxidase. Why would you make something that is more difficult for monoamine oxidase to metabolize? DMT is less specific a substrate for MAO than tryptamine, right? So that doesn't make sense. That's one. The other is that DMT is more lipophilic, unless it's quaternized. So of course, tryptamine can be quaternized as well. But adding methyl groups to it doesn't make it more polar, right? It makes it more lipophilic. So it makes it less water soluble and less likely to be cleared, right? So I never accepted that argument. And not just because I do a lot of research in DMT. It doesn't meet many of the basic requirements for defining a compound as metabolite. It is formed by biosynthesis of tryptamine from tryptophan, right? And there's a pathway for it. I mean, there's plenty there already to take care of tryptamine, and tryptophan, of course, is used for a lot of other things as well. But even tryptamine is considered a neurotransmitter, right? It acts at the traceamine receptor, the TAR, right? And people accept that. But for some reason, DMT, it's just a trash molecule. Well, okay, it's a known hallucinogen, and it's in the body. And so, I kind of see this as some blowback from the idea that hallucinogens should be readily available to people to use for therapeutic or even recreational effects. There are many people in the field that still think that we should not let the populace get a hold of these compounds, right? There are people that responded to the religious aspects of Rick Strassman's hypotheses, or to the idea that came, before Rick even wrote this, that this gave us an entree to the mystic unknown, that we could understand, much more about the world and the universe and ourselves. Take a trip, right? And again, they are against that idea that it is almost blasphemy to claim it. And some of these people are very vocal and very difficult to sit down and explain the scientific facts to. And I saw in Dave Nichols' response maybe some inherent bias, that for some reason he has a problem with Rick Strassman, or he has a problem with how Rick Strassman's ideas have been carried further by people on the internet, and that explains alien abductions, and it explains, but so what? We're scientists and we deal with facts. You can't stop people from trying to carry it further and dream and think of the other possibilities. I mean, why would you do that? I think that given his position in the field, that he has in a way damaged the ability of the research to go forward. And had it not been for the therapeutic breakthroughs, we might have seen another demise of hallucinogen research. And I think it has slowed the willingness of some to go into the research areas that John Dean has opened up, and that we've opened up with our data in research. We'd love to see other people replicate our results and go further. If you don't think this is true, prove it. Show me the data.
Yeah, I mean,
that hasn't happened.
That's a fair thing to ask for. Is if you're a scientist and you're offering criticism, then why don't you do a study to go ahead and either replicate it and show that it's not a real thing, or you can't just keep throwing out flimsy arguments, right?
No, he asked us one time, well, why don't you measure it? Okay. We've done that. All right. Now what? What's your answer now? I haven't gotten another answer.
Yeah, that was the issue I saw, is that there wasn't an acknowledgement of the progress. And that this goes for any sort of debate or argument, is that you have to acknowledge when, I guess, new information has come about, and you can agree on that, and then the argument can continue further, or it has to change, or it has to shift, or whatever. But the fact that wasn't acknowledged, it's a little bit, I pick up on that, and that's not very fair.
Yeah. Well, I know Dave, and I've met him before. We met when we were doing the documentary on the spirit molecule. And we had some interesting discussions. And I know his son. His son's a professor down at it's either the LSU Health Science Center or Tulane. It may be Tulane. And he's just recently sat on a committee. We published a paper together with a student here at LSU on PTSD. Right? And I've discussed it with him, about what the issue really was. And he and his father have actually published papers, questioning the significance of DMT. But he's so. I mean, his son. I think that this, like many other things, will pass, and that it will speak for itself eventually. I just don't want to see any unnecessary claims made that don't assist in either furthering this research or providing proof that we should or should not go down that pathway. I've seen no proof that we shouldn't.
Yeah.
I've seen plenty of proof that we should. So, you know, I was a little younger still, I'd put on my hiking boots and start on down that path again.
Well, I know I'm going to do my part to ring the bell and
yes, thank you, John. Do appreciate it.
Yeah, I mean, thanks for your work. I got really interested. Your work, Rick Strassman's work, Jima Borjigan, and obviously later on the young John Dean.
Yes.
You know, I really want to see this go further. I think that there's a lot of potential in terms of, you know, I understand some people have a background as atheists, some people are very deep in mysticism, but there can be a convergence of sorts once we have a better understanding of the mechanisms for our transcendental experiences. And I think that's much needed.
I think it is possible. We are on the horizon, looking out into the mist, you know, where eyesight dims, but there is a light, you know, that is visible, and we just need to make that light brighter. And I hope that the brightness of that light will allow us to finally see just what this thing called perception is, and perhaps allow us to better understand our true nature.
Absolutely. One last question before I let you go. I really appreciate your time.
Sure.
I know that you recently become an advisor for Pharma Drug. Can you discuss a little bit of the programs that's going on with that company and what you see going forward?
No, I can't.
That was a short answer.
No, I can't. Well, I tell you, Pharma Drug and PharmaTher, I really appreciate their interest in the field. There are, of course, a number of companies that are now springing up to get into the hallucinogen space and come up with therapeutics and be involved in this. I do know that there has been some work funded by PharmaTher at University of Michigan with Jima Borjigan to further carry on the research that she was doing when John Dean completed his dissertation. So she lost a lot of the people in her lab, and they have allowed her to pick that up and start back on it again. Exactly what she's doing, I can't discuss, but I haven't talked to them recently. It's been a little while since I've been required as a consultant in what they're doing. They may be up to something interesting. I just don't know right now. So I can't talk about that either. But yeah, it's an exciting time. I mean, I've been thrilled to see so many companies start to get into this, and you go online and you see the number of clinical trials that have either been conducted and we're waiting on the data to come out, or that are in process for these drugs. And of course, I published a paper just recently in Psychopharmacology about some of this. And the idea that there will be newer compounds that are both perhaps more hallucinogenic or specific, or compounds that do not have any of the hallucinogenic properties, but do have the psychoplastogenic and antioxidant effects, will be coming. This will become a very large and interesting area of research for private industry and the federal government, and that will benefit the people. That's what we hope for.
Things are happening finally. It's been a slow crawl, but been working harder. I appreciate all your work, Dr. Barker, just putting out so much knowledge out there for many years. A lot of people aren't really aware of your work, so I want to make them aware that, you know, if you want to want to read an authority on endogenous DMT and cohesive arguments for the importance of this molecule, check out Dr. Barker's work. I'll go ahead and link it all out on the DMT Quest website. I really appreciate your time today. Hopefully we can have another discussion maybe a year from now, or maybe 6 months from now, when there's more progression in the field. But I just want to say thank you very much for your time.
I plan to still be here.
You definitely will be, man. We need you.
And thank you, John. I mean, I think DMT Quest was a great idea, and it is information that the people need to know and understand, and you've gone a long way to accomplish that.
Thank you very much. I really appreciate it, and I look forward to all the big things in the future for everybody.
Me too.